Hello, this is Mrs. Butcher. This video is on fitting square root functions to data. Alright, so we're going to start off doing an example. We're going to find the inverse function of f of x equals 4x squared minus 16x plus 21. We've already talked about finding inverse functions, only this time we have a quadratic. So there's some different things we're going to need to do before we can do that. So step one, we're going to complete the square and write this in vertex form. Going back to fall semester here. So let's review here. I'm going to take f of x equals, and then I need to factor out the 4. So I have x squared minus 4x. And then I'm going to close my parentheses here and put my plus 21 out there. So I'm just factoring the 4 out of the first two terms. Then I need to complete the square. So half of 4 is 2 and 2 squared is 4. Means I need to add 4 here. But I need to also take away 4 times 4 from my 21. So now I have my 4, and then I can factor. This group is x minus 2 all squared, and then 21 minus 16 is 5. So there's vertex form. Alright, and then step 2 is what we did a couple days ago. We're going to switch x and y and solve for y, because now we've got it in a nice setup where we can do that easily. So I will make this x equals 4 parenthesis y minus 2 all squared plus 5. First thing we need to do is take away 5. Remember, we're going opposite PEMDAS here, so the next thing we're going to do is divide by 4. I'm just going to put over 4 so that these cancel out. Then I'm going to take the square root. So take the square root of both sides, makes that part go away. And then I need to add 2. So I've got the square root of x minus 5, and this is all over 4. And then my plus 2, equals y. And then the last thing I need to do is clean this up, because I can take the square root of 4, this 4 right here, and I want to have this in the standard form that I can use to graph it. So if I took the square root of a fourth, if I thought of this as the square root of 1/4 x minus 5, well, the square root of 1/4 is 1/2, so I would have 1/2 out here, and then the square root of x minus 5, and then plus 2 equals y. So there is my inverse. And notice I did not use plus or minus, and that's because I asked for the inverse function. And if I had the plus or minus, it wouldn't be a function. So even though it didn't specifically restrict the domain, we know, since it used the word function, that we're just doing only the positive part. And so now we have it with this 1/2 is our a value, 5 is our c value, 2 is our d value. And then you could graph that, which we're not going to do. Alright, so now we're going to talk about how to estimate a square root equation from some data. And I want to emphasize the word estimate, because we will be doing this with the calculator where you can get a more exact equation. However, first we're going to start with estimating. So I have this table. I'm sorry if it's a little bit blurry, but I'm in my car and it's really hard to write in here, so I'm just copying from my notes that I've already done. And I have number of bacteria and temperature in degrees Celsius. So what this is somebody did an experiment and they measured the number of bacteria in a certain amount of, I don't know, food or whatever in a sample at different temperatures in degrees Celsius, in refrigerators at different temperatures in degrees Celsius. So, like, there was 100 bacteria in the sample in the 1 degree Celsius temperature. There was 105 when the temperature was 1.4 degrees Celsius, and so on. And we want to take this data and we're going to plot it on a graph. And I just realized I have a mistake, so I'm going to correct it here in the video. So if you're just copying my notes, you're going to have it wrong. The x-axis is the number of bacteria. And the y-axis is our temperature in degrees Celsius. There, fixed it. So I've plotted, I made the little break in the graph because I have nothing less than 100. When I have 100 bacteria, that was at 1 degree Celsius. 105 was at 1.4, and so on. And I plotted these points as, you know, it's approximate because I just did it with my hand and a pencil, but I can see that it makes a curve that looks very much like a square root curve. And your instructions for figuring out a square root equation is to use the initial point as h and k. So that's why I put an h here and a k over here. And then pick any other point you want. I just went with 145 and 2.5. You can pick any other point you want. Another good point. For example, if I had one up here, I would probably ignore that one, right? But pick another good point to use for x and y. Plug them all into the standard form of the equation to find a. So we're going to assume b is 1. Because we could have it with a b instead of an a, but we're just going to work with a. So let's do some math. I'm going to plug 2.5 in for y equals a, we don't know yet, square root. X is going to be 145 minus h, which was 100, plus k, which was 1. So I could subtract the 1 and get 1.5 equals a times the square root of 45. And now I will divide both sides by the square root of 45. And because that's ugly, I will let you use a calculator. And we will get a is approximately 0.224. Ooh, that didn't work. Sorry. 224. So now we can rewrite our equation. Y equals 0.224 square root x minus 100 plus 1. And so that equation, that square root equation, pretty much fits the data points that we have. It's not exactly perfect, but if you were to graph that and look at it, it would be incredibly close. And we will be doing some estimating of the equations on the test, so even though you'll have a calculator, make sure you know how to follow this process. Alright, so finally, we're going to use the same data that we just used, but now I'm going to teach you how to find the regression equation in the calculator. Unfortunately, it's not as easy as it was when we did quadratics or cubics or any of those. This time, we have to enter the data into the calculator, and I put stat edit for you to remember, except there's not a square root regression option. So, we have to enter the data backwards, and please highlight star, circle, put stickers on it, backwards, and find the quadratic regression. Then, we take the inverse of that quadratic regression, just like we did in the first example, to get the square root equation. So, if you go in your calculator now, remember the x's were the bacteria, so we're going to put the bacteria in the y column, and we're going to put the temperature in the x column. Okay, and you've already got this written down in your notes, so I'm not going to rewrite it, but the x's will be the temperature, the y's will be the bacteria. Then you're going to hit Stat, Calc, Quadratic Regression, and here's what you should get. Ideally, you'd all be doing this right along with me, but I know you're not. You're just waiting for me to do it. You will get y equals 20.92x squared minus 44.14x plus 124.07. Like I said, I can't write very well in this car. All right, so now we need to convert it. So we need to convert it to vertex form. So we need to factor out 20.92. You're going to need your calculator for this because we need to divide 44.14 by 20.92, and you get 2.11. And then I'm going to leave a space and close the parentheses, and then have my plus 124.07. Now to complete the square, remember we take this middle term, half it, and square that. So you're going to have to actually use your calculator to do that. But we should get 1.11. And then remember you've got to multiply 1.11 by 20.92 and subtract it. I got 23.28, so subtract it from the 124.07. That's going to give us y equals 20.92 parenthesis x minus 1.06 all squared, because remember, this is just half of that, right? Plus 100.79. Then I need to switch x and y and solve for y. So x now equals 20.92, y minus 1.06 squared plus 100.79, and we're going to subtract 100.79 for both sides. We're going to divide both sides by 20.92, and we're going to take the square root. So I'm just going to put it here. Then I will be adding 1.06. So this is kind of messy, but if you leave it just like this is fine with me. You can give me x minus 100.79 over 20.92, the square root of all of that, plus 1.06. Or you could clean it up, take the square root of 20.92. Remember, we're dividing by that, so you're going to have 1 over, and then if you take 1 over the square root of 20.92, sorry about that, you get 0.22. So that's in front of the square root of x minus 100.79 plus 1.06. So that's the equation we got in the calculator. And if you notice, it's very similar to the one that we got before. We had a 0.224 here. We had a 100 here, and we had a 1 here. So it's very close. The estimating it's a little easier, but if you need something more exact, then the regression is the more exact. It's the way to go. And unfortunately, the regression for square roots is a lot harder than any other kind. So I'm sorry. We're going to practice some of these in class tomorrow, and you guys don't worry about it. Just do it a few times. You'll get good at it. See you tomorrow. Bye.